Okay, today we're going to look at parallel and perpendicular lines. Still using the y-intercept form because it's the easiest form for us to see how things work. So let's start off with our standard line, y equals x. As we know, it has a gradient of 1. For every 1 up, it goes across 1. So that's our gradient. It passes through the origin, so it has no variable. If we have a parallel line, we could have a line like this, y equals x plus 4. You'll see that the slope of the line is still rise of 1, run of 1. So the coefficient of x is still 1. As for this line here, it's also another parallel line. So all three of these lines here are parallel. Y equals x plus 4, and y equals x minus 3. Parallel lines never meet. The coefficient of x in a parallel line is the same. E.g., y equals 2x and y equals 2x plus 4 are also parallel lines because the coefficient of x in both equations is 2. Now if we go back to here, we can look at also at perpendicular lines. Now in a perpendicular line, perpendicular lines they form to meet right angles. So if I'm to go here and I put in the equation y equals minus x plus 3, it meets at a right angle. Because I've made it minus 3, it moves the line down. So we know this line, usually we see it up here, y equals minus x. But if I translate it down and make it go through here, doesn't matter, y equals minus x minus 3.04 is this line that passes through here. But most importantly for this exercise, we're looking here that it forms a right angle where the two lines meet. It doesn't matter if I move it anywhere, up or down, wherever they meet, they're always going to meet at right angles. So let's look at another pair of lines and see how they meet. So here is y equals 2x. Let's have a look at y equals minus 2x because we know that y equals x travels upwards. We know that y equals minus 2x travels downwards. But you can see that those lines don't meet at right angles because they rise is 2, and in the green case it goes plus 1, and in the red one's case it goes negative 1. So they don't meet at right angles. Let's try the line y equals, we know it has to be negative because it needs to travel from the left to the right, so it needs to be negative. And let's try a half x. Now I haven't drawn this before because this program, it changes the numbers to decimals. So we know a half is equal to 0.5, and so when we put that line in there, you can see now that the black line is traveling at right angles to the green line. So perpendicular line meet and form right angles to the coefficient of x meet to form right angles. The coefficient of x in a perpendicular line is a negative reciprocal. E.g., if we have the number 2, it's the same as 2 over 1. So our negative reciprocal is minus a half. If we have minus 3 over 2, our negative reciprocal is positive because the sign changes, 2 over 3. So it's the reciprocal of 3 over 2, 3 over 2, becomes 2 over 3, and the positive becomes negative. So our perpendicular lines, the x is in the perpendicular lines is the negative reciprocal. So another example, let's look at minus 2x. So minus 2x plus 4. So we're looking for a line that goes in the opposite direction. So we're looking at a line that is going to be y equals. So this is minus 2x. So our sign needs to be positive. The reciprocal of 2 is a half. 1 over 2x. And there's our line. Here is at right angles. So it doesn't matter if we move this line up. Obviously the y-intercept changes, but the coefficient doesn't. If we move this line, again, you'll see that the variable, the y-intercept changes, but the coefficient doesn't, and the right angle continues. Okay, so that's how we do parallel, or we work out what parallel and perpendicular lines are.